Hi, are you ready to learn about the photonic device simulation workflow in VPIdeviceDesigner? Let's get started. Most integrated photonic devices are based on a waveguide cross-section. Therefore, after importing the VPIdeviceDesigner Python modules and defining all materials, the first step is usually to define and analyze the waveguide cross-section. Once that is defined, the 3D device can be easily derived from it. Now follows the heart of the device design: simulating the wave propagation, extracting the S parameters and optimizing the design, and exporting the final layout. The example I would like to show you is based on a 1x2 MMI. Since we are working with Python, we need to first import all the necessary libraries. This includes standard Python libraries as well as our device designer's specific ones. Next, we need to define the objects that can represent the materials we would like to use, in this case silicon on silicon dioxide. We can depict the materials properties using matplotlib libraries on demand as shown below. Now we need to assign these materials to the correct sections that construct our waveguide, and here is how it looks. Since the mode solver is finite-difference based, we need to mesh our waveguide cross-section. We then pass both the layout and the mesh to the mode solver to calculate guided modes. Based on the calculated modes, we can design the 3D MMI device. We extrude the analyzed waveguide cross-sections into 3D waveguides of different width and length, assemble them into one device, and add ports as inputs and outputs. The device is now ready and we can propagate the light through the MMI. Here we use our eigenmode expansion method, which is very efficient for devices with a piecewise constant cross-section such as this MMI. For devices with continuous varying cross-sections, we offer the beam propagation method. Of course, we have the possibility to evaluate the field at the output ports of the MMI and calculate the S matrices. This information can be exported and used later on in a circuit-level simulator VPI component maker photonic circuits. At the end, in case the device fulfills the design constraints, its GDS layout can be exported for fabrication and also included in a custom PDK. As you have seen, the simulation workflow is a robust framework for a wide range of devices, giving you the flexibility to easily add advanced features like tolerancing and optimization. To see how this powerful workflow can apply to your specific projects, get in touch with our team.